So now we're talking about getting data off a microcontroller and sending it somewhere else. And this kind of might be obvious, but there are a couple different patterns, and we're going to try and cover them in the less than 10 minutes we usually take. And so basically there are two ways to get data. Well, I mean, there's more than two, but let's bucket them in two ways. One of them is a push model, and the other is going to be a pull model, right? In the case of the push model, the microcontroller sends the data itself. And in the case of a pull model, the recipient actually initiates a connection and asks for the data, and the microcontroller provides it. But either way, we're moving data off the microcontroller. So if we think about that, right, I took this little tiny Pico thing here and put a couple ideas on it. So on the left-hand side, what do we have? We have the normal debug route. We've got the kind of remote peripheral host route, right? I can have a PC or a server or some kind of device and plug a microcontroller into it over a variety of links. And I talked about this earlier, what a USB connection could look like. But basically, all I did was CDC here, which is virtual serial port. But it could be a MIDI connection, like actually a device could be a HID device and pass data from a microcontroller to a computer that was plugged into as and emulate a keyboard or something. I'm going to assume we're talking general data and not like a HID device, HID, human interface device here. Why would I call it a HID device? That's like an ATM machine. So typically you'll see these in a developer environment, and we also have big production, but in a developer environment, you'll plug a USB connection in and you'll get a control plane, kind of a quasi-control and data plane connection. You end up with the console, and the console on MicroPython could be a REPL. On others, it would be the debug output. And they could also not just basically they would use the debug output as data. Print 5,6, print A, B, print X, Y, right? And the way these work to get data off is you can have that console, but sometimes you might want a binary data connection or some other custom data connection whose data stream wouldn't get intermixed with the console. You can actually do this on MicroPython. CircuitPython. You can actually create two connections at once. One will be the console, which will be your control and debug plane, and the other would be your data device. The other one here is you can do a regular serial cable, right? A lot of these things have UART pins, and you're not doing USB, you do some kind of serial cable. It could be regular TTL level. It could be some RS-485 or some differential driver long distance thing. The other one here, back to the host, really Bluetooth is always going to be plugged into a host on one end. And so it's really not a cloud thing. You can't do remote Bluetooth. Well, I mean, you kind of can through the web. Anyway, so the net is, in this case, we would initiate a Bluetooth connection to the host, and we would push data so that everything is flowing from the microcontroller on demand. And what does that mean? That means we could generate the data send the data as it's generated, right? And if the protocol is lightweight enough, we might get a pretty high bandwidth on this. And for these serial connections, we can just stream it, right? There's no opening and closing the connection continually. As long as it's open, we're good. We write to it. And then we got to figure out basically how to pack it in the right format. Are we going to do something binary, do something text, that kind of thing. So that's the left side. Typically, if you're in debug mode or doing home projects or stuff like that, you can do that. Sometimes I'll do the Bluetooth. I'll put the microcontroller in a remote thing. It's doing data gathering. Now, remember, if you're only pushing out, that means you're just telling other folks what you're doing. If you needed bidirectional control, that would be pushing data onto the device, and that's in a different talk, even though it'll show up a little bit in the picture below, right? So the other option is I want to go global. On the right-hand side, well, another option is I want to go global, or I want to go to something I'm not hardwired to or not virtually serial wired to. So what are the obvious ones? I can publish stuff to MQTT and to message buses or cloud storage. I can actually make remote calls to the cloud. I can send stuff to an IOT hub. A lot of those tend to be a message or an event stream. And basically, we open a wired or wireless connection to some server or service. Like in the case of a message bus, it could be on my home automation hub. It could be running on a server locally. It could be in the cloud. But typically, these tend to be connections that may go up and down, right? Or you might try and keep them persistent so you can stream data more timely. But like if it's a remote web API, you could do persistent sockets, but a lot of times you're just going to open and close the connection, right? and you're going to have to be able to reopen the connection because it could drop. So on the left-hand side, we tend not to have a lot of connection semantics. Once you're up on a Bluetooth serial link, it just looks like any other cable. For the ones on the right, we have connection management to do, but you can push the data, binary or text, to those. And the nice thing is if you use any of those for pushing the data or the Bluetooth for pushing the data, then your console, if you're on a system that doesn't support multiple serial channels on a USB link, you can still use that for debug. So you can put that thing remote, walk up with your laptop or phone, plug into it, or connect with Bluetooth, get the debug output while it's still talking to the remote. The one at the bottom, sometimes you end up in processor-to-processor communication or processor to many processors in some kind of mesh or fan out. You could have one of these that's a hub connected to the PC, and the others are all connected, either wired or virtual wire, which would be wireless, sending data to this, and this is a communication multiplexer, and it sends it across the link. So I just wanted to call out, right? You kind of have a lot of these quasi-standard serial, typical serial operation where you actually think of it as serial, and the ones on the right-hand side are actually serial, but they're really talking to some things that's more complex, more remote. And if you get a lot of fan in or fan out, right, you could have thousands, hundreds of thousands of these controllers. Typically those connections for outbound data, sensors, anything else, for transfers that are initiated from that host, a lot of those would go into these hubs and broker concept, right? And then the reverse of this for getting data, of course, is really the remote side asking for the connection. Now, who initiates the connection and keeps it persistent? It could be either way. So some of the things that go about this request, response, or push are who can make a connection, who can connect off a network, what network's reachable, who's going to have a routable IP. If the devices don't have routable IPs that can be seen from other places, then you're in a push model. You got to send it out, and you might even make a remote connection and pull data from the remote. We'll talk about that another time. On the other hand, if the remote services can reach your device, or if the device makes a connection and keeps it up, then these services can talk and say, I'm ready for data now. I need data now. I need data now. I need a status. And so that would be either a command response or a request response, the remote side. So let's not confuse setting up the connection and asking and pushing the data, right? So in this case, we're really talking about a connection's been established and the remote side is like, I think I need data now. And so that's what these are. And that works pretty well. Like that's the case where maybe these devices are in public and they can't route out. I don't know, whatever. Anyway, so request response is pretty common. Send me the data in this format. Now send me this data in the other format. If you're in a push model where there's no control on the receiving side, then basically it's the microcontroller's job to set up and send some kind of regular data or document at the whim of the microcontroller. So you can think of these as producer-driven updates, and you can think of these as consumer-driven updates. What was the other thing I was thinking of here? Don't know. Oh, batching and individual updates, right? So whenever you're sending data, like in a push model, you can send data as you get it. And there are two ways that you would be ready. One would be periodic. You actually need to transfer the data every 30 seconds, every 5 minutes, every hour, so you can build a byte stream or a data stream at regular intervals. Another would be trigger-based. Whenever anybody opens the door, send an alert to the cloud. Whenever the dog barfs somewhere in its kennel, it sounds like it's barfing. I do have like a IOT vision. Is that dog barf in the kennel, right? That we don't need to have it send data. It didn't barf. It didn't barf. It didn't barf, right? And oh, it did barf. So in that case, that might be interrupt driven or switch driven, that kind of thing. So we have a couple axes to think about if we're pushing data off the controller. Does the controller initiate the transfer? Does the remote side initiate the transfer? Are the transfers periodic? Are they data event driven? And will you batch it? It turns out some of these connections might be real. Like I'm on some weird cellular low bandwidth, LoRaN, whatever that one is, kind of a low bandwidth. I might want to do batches. I'm only going to send 10 updates at a time because the connection's really expensive to set, right? And so if the setup and call time is expensive, or maybe I pay to initiate, this is a dialer, and I pay every time it dials. We used to do that. In that case, batching might make sense. So that's it. This is putting patterns for moving data off of a microcontroller. Are you going to push the data, or are you going to pull the data? Are you going to do it triggered? Are you going to do it time-based? Are you going to send one data point at a time, or are you going to send a batch? That's it, 10 minutes. We'll do the other side of this in another talk.